given to you is the y equals mx plus b. All right. So anytime you see a line and it has y equals and then some number times x plus b, that's your slope-intercept form. So we'll start with the b. The b represents your y-intercept. What that means is where a line crosses the y-axis. So if you can think of your coordinate plane, your xy that looks like a plus, you know, the line crosses that line at its y-intercept, and that's your little b. And then the m, the number in front of the x, represents your slope. So what slope means, it's just, think of it as like a slope of a hill, like if you were going down a ski slope, right? And so that just tells you how sharp you move from there. And so like a positive slope goes up from left to right, a negative slope goes down from left to right. Okay? And that's what looks like most of these are in. A couple of things that it's asking on this page are things like perpendicular. Okay, so when you have perpendicular lines, those are lines that form right angles, right? They're perfectly the opposite directions of each other, right? Perpendicular lines always have slopes that are negative reciprocals of each other. So what that means is, let's say you have a slope that is like 4/5 for one. The perpendicular line will be negative 5/4. Or if you have a slope that is negative 1/3, the perpendicular will be positive 3. So you just literally take the slope of one line, you flip it upside down, and you change the sign. And those are perpendicular lines. The other special case are parallel lines. Parallel lines have the same slope. So if one line has a slope of 2/3, the other line will have a slope of 2/3. Those are parallel. Okay, so 57. It says, it gives you line A and it gives you the equation of line A. Y equals 2/3 x plus 1. So the first thing I want to 57, it says line A is given by the equation y equals 2/3 x plus 1. So if I were to look at that particular line on a graph, it would cross the y-axis at positive 1. And then the slope is 2/3. So the slope of 2/3, the top number, tells you if you move up or down. And the bottom number tells you if you move left or right. So this is a positive slope, so I'm going to go up 2. And I'm going to go right 1, 2, 3. And that gives me that particular line. This question wants to know which of these lines is perpendicular. So in order for you to determine that, it has to be in slope-intercept form. You can see that A is in slope-intercept form, right? The slope of A is 2/3, right? Well, that is the same slope, so it's not perpendicular. That one's actually parallel. The next one is negative 2/3. That's negative, but it's not flipped, right? So that's also not going to be perpendicular. The other two are not in slope-intercept form, okay? So in algebra, if I want to get this in slope-intercept form, I'm just going to solve for y. So what I mean is I'm going to move that whole entire 3x group over. So it would look like this. 2y equals negative 3x plus 6. Just moving that whole group across the equal sign. Then I'm going to divide everything by 2 because I still don't have y by itself, right? So now it's y equals negative 3/2 x plus 3. That one is the flip of 2/3 and it's negative. So that one is going to be perpendicular, all right? We do want to check the other line though, right? Because it may have more than one answer. I don't know. So we're going to do the same thing to the other line. we're going to flip that guy over, move the 2x over. 3y equals negative 2x plus 9. You can see if we divide by 3, you're going to get negative 2/3. So that one is not going to be perpendicular. It's going to be just like B. It's going to be negative, but not flipped. So C is your only answer there. All right, if we look at 58, they've asked this a little bit different way. What is the equation of a line that passes through the point negative 1, 4, and is parallel to the line y equals negative 3x plus 6? Okay, so parallel, so I'm going to write my y equals mx plus b. All right, so I'm going to take just regular y equals, and I'm going to write that out, mx plus b. What I do know about this line is it has a slope of negative 3. I know that because they said parallel to the line they gave me, and the line they gave me has a negative 3 slope. So I'm going to say, well, my y equals negative 3x plus b. Well, I still need to know the b part of it, right? So I've narrowed it down to a or b as my answers because those have the right slope, negative 3, right? But now I have to figure out the b. Well, they gave me a point. They gave me negative 1, 4, which is my x and my y. So I can take my y equals mx plus b and now plug in x and y and solve for b. So I'm going to say y is my 4. 4 equals, I know my slope is negative 3. My x is negative 1. And then I have plus b. And then I just solve for b. So I have 4 equals negative 3 times negative 1 is 3 plus b. Then I subtract the 3 over. I get b equals 1. So now I know my equation should have a slope of negative 3 and a y-intercept, or the b, of positive 1, which gives me answer B. So if we look at the next one, 59, it says, which graph represents the situation? Nana has read 30 pages of her book so far. Each day, she reads an additional 10 pages, okay? So think back to y equals mx plus b, okay? Anytime they give you a starting point, she's already read 30 pages. You can think of that as your b, your y-intercept. That is where you start on the y-axis. So in this case, on the y-axis, you're going to start at 30. Then when they give you a amount per something, like 10 pages per day, right? That is your slope. That's how far you're moving each day. So for this one, her starting point was 30. So you're going to look for a graph where she starts at 30. That actually answered your question right away, because only one of them starts at 30. But let's say multiple started at 30, right? Then you would look for the graph that starts at 30 and goes up 10 every one day. So up 10 pages every one day. Does that make sense? So anytime they give you a starting value and a per something value, your starting value is where you start on the y-axis, and the per day or per whatever is how you move from that point. So what do you think are the keywords in 60? There's a couple key things in that 60. There we go. That indicates you might have more than one answer. Right. So that equation is in y equals mx plus b, right? So just looking at that, do you think that line should be going up or going down, and why? There's a minus 3. But which one of those, mx, and m in front of the x or the b, tells you how you move? Okay, no, you're good. If we look at 59, we started at 30, that was our b, and we moved by 10, up 10 over 1. In this case, where are we starting? So where should you start on a graph for y equals 2x minus 3? What's your starting one? Do you remember which one is your starting one? So the number that's, yes, the number that's all by itself is the number that you start at, -3. So -3 just represents where you start on the y-axis. That 2 represents how you move. So to determine if a graph goes up or down, you look at the number in front of x. And in this case, the number in front of x is positive. So automatically, we know that C is not an answer, because C is a slope that's going downhill from left to right. And the slope of the line they gave us is +2, up from left to right. Do you see that? So we can already eliminate C. The only thing we have to decide for A is it moving the right way? So first, did it start at -3? 1, 2, 3. Yep. It started at -3. Okay. Did it go up 2? Well, yes, but how do we know how far over? You can always write a whole number as over 1. Okay. So because you can do it as over 1, then you can say I can walk from that -3 and go up 1, 2, and over 1. And you can see that A is a perfect representation of that line. It started at -3, it went up 2 and over 1. That is that line. Now there's a couple ways you can do B and D. An easy way is just plug in your x's and see if you get your y's. So like plug in a -2. 2 times -2, because I'm just plugging it in for x. 2 times my x, -2, minus 3. -4 minus 3 equals 7. Well, that one works. 2 times 0 minus 3. That's -3. That works. 2 times +3 minus 3. That's +3. That works. And 2 times 4, 8 minus 3 is 5. So if you plug in all your x's for B, you get those y's. Like, that's one way to check, for sure. Do you get from x to y by multiplying by 2 and subtracting 3? And then you can see if that one works, then does the other one work? Well, you can plug them in and see. 2 times -1 minus 3 is 5. That works. 2 times 0 minus 3 is -3. That works. 2 times 1 is 2. Minus 3 is -2. That does not work. And 2 times 2 is 4. Minus 3 is not -1. That does not work. So in order for it to be a good representation, all of them have to work, and they don't. So D does not work. Okay, so let's look at 61. It says, given the graph of f of x, which statement is true? So f of x just means your y value, your output. So if you put a number into the function, what number do you get out of the function? So the number in parentheses on all of these, you can think of as your x value, and what that equals, you can think of as your y value. So you can look at this and say, okay, my x value on A is +2, okay? So go to your x, that's +2, and is your y value there -2? No, it is not. So if I look at the graph and I go to the coordinates 2, -2, if I had just had to graph that xy, 2, -2, the guy in parentheses is my x, what it equals is my y, you can see that 2, -2 is not on that line. Do you see that? So then look at the other ones. Your number in parentheses being the x, and what it equals is your y. See if those are on that line. So let's look at B. What numbers am I looking at? What is my x and my y value of B there? Your x is 4 and your y is 1, so go to the point 4, 1, and is that on the graph? So look at 61. If I'm looking for the point 4, 1, I'm going to start at the center and go 1, 2, 3, 4 to the right and up 1. So that is an answer. That is on the graph. B is on the graph. So if you check the other ones, and I would always check them just in case some of these have more than one answer. Let's look at 0, 1. So if I don't move any left or right and just go up 1, am I on that line that they've drawn on the graph? No, so that one is not an answer. And then let's look at the last one. -4, -3. So that means if I go left 4 and down 3, am I on the graph? I am, so that one is also an answer. So that's all f of x means. The part in parentheses is your x value, which you put into the function. And then the equals is what comes out. So what the answer is, the y. You can think of it as input, output. What you put into the function, what comes out of the function. Which actually leads directly to 62. Domain, that word means input or your x value. And then range means output, what comes out, or your y value. So they gave you a function. G of x just means y. Y equals mx plus b. They just gave you that. They just wrote it as g of x. Y equals 1/2 x plus 3. It says which domain will give you a y, so which x will give you a y of 5. So if I plug in these numbers for x, do any of them give me 5 as my answer? And I'm just plugging it into the right side. When I say plug it in for x, remember I'm just putting it into the function, the 1/2 x plus 3. So if I plug in 16, 1/2 of 16 is 8. 8 plus 3 is 11. That does not equal 5. So if I say 1/2 times 16 plus 3, that does not equal 5. If I plug in 1, C, if I plug in C, 1/2 times 1 plus 3 does not equal 5. So that one does not work. 5.5 is definitely not going to work, but that's okay. And then if you look at D, 1/2 times 4 plus 3. 2 plus 3 equals 5. Yep, so that one works. So they're just giving you new terms here for x and y. That's all domain is. Domain is x, range is y. Domain is what you put in the function. Range is what your answer is after you've figured it out, after you've simplified it with order of operations. So it says select all. First of all, there's your keyword, all. You're looking for possibly more than one answer. All that are functions. So functions just mean that every x will only have one y answer. Now, it doesn't mean that multiple x's can't have the same answer. They can. But it just means that if you have one y, it's not going to have, like, let's say your x is 2 and you put it into your equation. You shouldn't get like 4 and 5 as an answer. That's not how this works. I like to relate it to like when you're ringing stuff up at the grocery store, okay? Have you ever done self-checkout at the grocery store? So they all have barcodes, right? Those are functions because if you scan a barcode, it should only give you one price, even if you buy multiple of the same thing. So if you buy 2 loaves of bread and they are the same brand and the same exact bread, when you ring up that barcode, it should give you the same price, right? If you ring up the same barcode and it gives you 2 different prices, we have a problem, okay? And that's not a function. So if you buy bread and let's say it's $3, every time you ring that barcode for that bread, it's only going to give you $3. You can think of the barcode as your X, the input, and the $3 as your Y, the output, okay? However, that doesn't mean you can't also buy cookies and the cookies are also $3, right? You could have a different barcode that also gave you $3. That's not a problem. It would only be a problem if the same barcode gave you two different prices. Okay, and that's how functions are. So if you look at C, the one you chose, your input was -1 and your output was 0. That's like the barcode was -1 and the price was 0. That's fine. When you put in a 2, that was your input, barcode. 3 was your price, output. That's fine. And when you put in 4, a different barcode, it was also $3. That is fine. That is a function. Okay? Does that make sense? All right. If you look at D, the X's are all your inputs. The Y's are all your outputs. You do not see any of your X's repeated, right? -1 gave you 2. 0 gave you 2. 1 gave you 2. And 2 gave you 2. That is perfectly fine. It would only be a problem if you had seen -1 gave you 2 and -1 gave you 3. That would be a problem. But the fact that multiple X's gave you the same Y value, that's okay. That's like having 4 different things that you bought at the store and they were all $2. That's okay. So D is also a function. So that's how you tell it. When they give you numbers, you just check and make sure that your X's only give you one answer. So if they do it like C, you should never have 2 lines coming off of one X. You can have multiple X's going to the same Y, but you can't have 2 different lines coming off of one X, or else it would give you 2 different answers. Same thing. Does that make sense? Same thing with D. If it's only listed once on the X's and only has one answer for it, that's okay. Now, what if they give it to you like a picture, like on A and B? There's a much easier way to tell when it's a picture, okay? When it's a picture, there's something we call a vertical line test. The vertical line test literally means you can draw a vertical line, meaning up and down, and it can only cross the graph one time. Wherever you draw it, it can only cross it once. So the difference between A and B, A, no matter where I draw a straight up and down line, I'm only going to touch that graph one time. But on B, if I draw a straight up and down line, it's going to cross that one 2 times. Do you see that? So if I were to draw a line on A, no matter where I draw it, one time, that means A is a function. But on B, if I draw it, a line, you can see it crosses twice. That one is not a function. So all of those are functions except B. All right, let's look at 64. Remember, domain is your X value, okay? So domain is your X's, your first numbers in your groups. Range is your Y value, your second numbers in your groups. It says which relation has a domain of -1, 4, and 5. So you're going to look at A, B, C, and D, and you're going to see which of those only has the first digits that are either -1, 4, or 5. So do you see any of those that have a first digit that are -1, 4, and 5? Even if they repeat, it's okay because this is just a relation. No, so your domain is your X value. So you are trying to figure out which of those, even if it's more than one, has the first digit of those pairs as -1, 4, or 5. So let's look at A. Are the first digits -1, 4, and 5 for A? Even does not have to be in order. Good question. Yes. So that domain works. So we're going to move on to the range. So A is a possibility. So the domain works. Now the range is your second, 0 and 1. You can only have 0 and 1 as your second value. Is that true for A? No, because of that 3. You see that 3? He can only have 0 and 1, so A does not work. All right, what about B? Domain, -1, 4, and 5 for my first values. Yes. What about only 0 and 1 as my second values? If it's a relation, yes, it is. If it's a relation, this isn't a function. This is just a relation. So relations are any pairs. So are your second values there only 0 and 1? Yes, so B fits that description. We're going to check all the others just in case it's a multiple answer. So what about C? -1, 4, and 5 for your first numbers. What about your range? Why not? Perfect. Perfect. Yep. And what about D? Check your domain and your range there. Why not? Perfect. Perfect. That is correct. All right, so the second page are not going to be lines anymore. They're going to be what's called parabolas, okay? Parabolas. So parabolas, the difference between a line and parabola, when you see a line, it just has a y and an x. When you see a parabola, it has a y and an x squared, okay? Parabolas are shaped different too. Parabolas look kind of like U's. Fun fact about a parabola, it comes from the same root word as parable, like in the Bible. It means to run alongside. So just like Jesus would tell a story and it would have a meaning that came alongside, the parabola has that U shape with those two lines that run alongside it, okay? So parabolas look a little different. They have an x squared, and their standard form is y equals ax squared plus bx plus c, okay? Because you have the x squared piece, the x piece, and then the number without a variable, the constant. So some of these questions are asking you about the term vertex. So every parabola, because it looks like a U, is going to have a lowest point or a highest point. If it is facing up, the vertex is always the very bottom. If it's a parabola that's facing down, the vertex is going to be at the very top, okay? So you can just look at a parabola's equation and tell if it is facing up or down, and that is with that very first number in front of your x squared. If the number in front of the x squared is positive, then your parabola is going to be up like a smiley face. If your a, which is easy to remember, the number in front of the x squared is negative, and negative people frown, so it's going to look like a frowny face. Okay, it's going to be pointing down. So you can very quickly tell if it's pointing up or pointing down. Now, if it's pointing up, then that means your vertex is going to be the minimum or the very lowest point on the graph. If it's pointing down, you can think of a hill, then the vertex is going to be the maximum, the very top of the graph. Okay? So there's some shortcuts to finding your vertex, and you can use this parabola to do it. So at the very beginning, I said it was ax squared plus bx plus c. You can find, it's going to be a point, x, y. Okay? To find your x of your vertex. To find your x of your vertex, you're going to take that b and do the opposite sign, negative b, and you're going to put it over 2 times a. That will give you the x value of your vertex, your highest or lowest point. To get your y value, you just plug that number in and get your answer. So we're going to do one together. 65 says, given the function f of x equals 2x squared minus 4x plus 1, determine the vertex and whether it is a max or a min. All right, so before we even try to find the vertex, we're going to look at this and say, would it point up or point down? So I'm going to look at the number in front of my x squared. What's the number in front of the x squared here? Positive. So do we have a smiley face pointing up or a frowny face pointing down? Smiley face, that's right. So our graph is pointing up, which means if it's pointing up, then my vertex is at the very bottom. So my vertex then is a minimum. Correct. We have just eliminated 2 answers right away without doing anything, okay? Now we're just going to figure out what our vertex is. So remember, there's a shortcut. If it is 2x squared minus 4x plus 1, we take the number in front of x. So what's the number in front of x? Just the x, just the regular x. Technically, negative 4, okay? So we take that negative 4 and we use the opposite. So instead of negative 4, we're going to use positive 4. If it had been plus 4, we would use negative 4. Always use the opposite. We're going to say negative 4 is on the top, our numerator. And on the bottom, we're going to say 2 times a. Well, a is the number in front of x squared. So what was the number in front of x squared? What's the number in front of x squared? No, the number in front of x squared in our original function up at the top there. There we go. So we're going to say negative 4 over 2 times 2. Negative 4 over 4, which is negative 1. That is the x value. Oh, positive 4, sorry, because we changed it. So positive 1, that is the x value of our vertex. We have just figured out our vertex and we don't have to do anything else. Only one of those leftovers have an x value of positive 1. What is that? There we go. That's our answer. Next one. Given the function, this is a parabola, right? It says determine the range of the if the domain is that function, and if the domain is all real numbers greater than 1. Greater than 1. So they want the range if the domain is all real numbers greater than 1. All right, so this is kind of a tricky one because the range is going to be the y value. So if you were to draw this graph, it's going to be where your y numbers are going. So if you look at negative x squared plus 6x, is that a plus 5? It's kind of wrinkled on my end. It's minus 5, okay. So minus 5. All right. The first thing I want you to think about is this guy pointing up or down? Is he a frowny face or a smiley face? And how do you know that? There we go. Perfect. There's a negative. All right. So that means my y value is going down forever. Do you see that? Okay. So if it wants the y value and it says all numbers greater than, that's not even possible for this. Do you see that? Because your y value is going infinitely down. So it can't be all numbers bigger than 4 or bigger than 3. That would mean it was going up forever. This one's going down forever. So I automatically know that A and B can't be the answer. because they're asking about range, which is y, up and down, and this graph is pointing down. So there's no way that this guy is going to be going up, greater than. So I automatically know it cannot be A and B. If it had been pointing up, it could have been greater than forever. But he's pointing down. So I know my y value has to be less than some number. I just have to figure out which number. Okay? Now, the next thing they said is it's all real numbers greater than 1. Greater than 1. So I can plug in a 1 to the x's and try to figure out what my y value would be. So if I plug in a 1, I would say negative, and then 1 squared plus 6 times 1 minus 5. So I get negative 1 plus 6 minus 5. Looks like 0, right? And so I'm going to, let's see. That is going to be 0. So then if I plug in a 2 greater than, we'll say negative 2 squared plus 6 times 2 minus 5. So if I plug in a 2, I'm going to get negative 4 plus 12 minus 5. That's going to be 3. So the next number bigger than 1 is going to give me a 3. So that's the highest number I'm going to have there. So which of those tells me that it's going to be less than or equal to 3? Yep. We have, what is the equation of the quadratic function shown on the graph? So you can eliminate 2 of those immediately, and can you tell me which 2? That's right, B and D cannot be it. Why? Because I have a smiley face right there. So I automatically know that B and D are not the answers. Done. I automatically know. They're frowning, right? They're frowning. Now, there's a couple ways you can do this. One of the easiest ways to do this is to look at the x and y that they gave you. So they gave you 3 points on the graph. They gave you negative 1, positive 1, 0, negative 1, and 1, 1. You see that? So you can literally plug in the x to your x and see if it gives you your y. So the point they gave you, I'm going to use 0, negative 1, because that's the easiest guy to plug in. 0 is my x value. So if I take a and I plug a 0 in for x, y equals 0 squared plus 2. I get 2 as my y value. That is not the y value they told me I should get. They told me I should get negative 1. So I know a is not it. If I plug in to c, if I do the same thing, y equals, and I say 2 times 0 squared minus 1, I get negative 1, which is exactly what they told me I would get. So you can just take one of the x, y's and plug it in and see if it's true. Plug the x in and see if you get the y they think you should get. X is your input, that's what you put in. Y is your output, that's what your answer should be when you plug in the x. Okay, does that make sense? Perfect. So let's talk about this next question. This next question is very detailed, okay? So a couple things we haven't talked about yet is flipping. We have talked a little bit, you haven't realized we have, all right? So your basic parabola that doesn't have any movement, it's just a smiley face right at 0, 0, is y equals x squared, or the one that they gave you in 68. So this is f of x equals x squared is your basic parabola. That's a smiley face right at your 0, 0. Okay, now you can do some things to that guy. If you put a negative in front of it, it flips him upside down, right? We've already talked about that. So if I put a negative in front of my x, it's going to flip it across the x-axis, down. It's going to flip it down, okay? That's what reflect means. Reflected over the x-axis means flip it upside down. So you already know how to do that. So it says which one of these flips it over the x-axis. Well, you can eliminate 2 of these right away. You know 2 of these do not flip down, right? Which 2 do not flip down on 68? Correct. So C and D are automatically eliminated. Then it says it is stretched, okay, by 3. Now here's the thing. A and B both have a 3 in them. But stretching happens when you put the number right in front of the x. When you add or subtract a number from an x squared, it moves it up and down. So that first one, plus 3, is just going to be taking a frowny face and moving him up 3, still pointing down. But when I multiply the negative x squared by 3, that b, that's the one that stretches it. So if you multiply a parabola by any number bigger than 1, it's like if you were taking Play-Doh, like a Play-Doh parabola, and pulled him up and down. And it makes him very skinny and tall, okay? And so the plus 3 just takes the smiley or frowny face and moves him up and down. But the 3 right in front of the x squared stretches him. So he's still pointing upside down, but he's tall and skinny. And if you were to put like a fraction in front of him, it squishes him and it makes him short and fat. So the one that flips him upside down and stretches him would be B here. All right, so now we're getting into factoring. Do you remember factoring? By chance? Slightly. Okay. It says based on the graph below, select all the factors of f of x. Okay. And then 70, which is equivalent. So x minus 3, x plus 3, x minus 1. All right, so I'm going to start with 70. So factoring, the way that you're going to factor these guys is like, I call it unfoilings. Do you remember foiling? Like when you have 2 groups and you multiply across each piece.
Thing to make it light for the color.
Remember that?
No.
Or have you done that? So like if I were to take A and I were to say to foil it, actually A is going to be my answer, so I'll do a different one. Let's take D. We're going to foil D, okay? Foil just means to take the first terms, x and x. If we're looking at 70, number D, letter D. Foil means to take x times x. That's my first term. X times x. And that gives me x squared. And then we're going to do our outer terms. X times 10. X times 10 is 10x. Does this sound familiar? Then inner, negative 3 times x is negative 3x. And then negative 3 times positive 10 is negative 30. And then you just combine your like terms. So x squared doesn't combine with anything. A positive 10x and a negative 3x is a positive 7x. And then the negative 30 doesn't combine with anything. So that's foiling. Factoring is unfoiling. So you're going backwards, pretty much. So there's a couple ways to do this. If you don't know how to factor, you could FOIL all of these and see if your answer works, okay? One quick way to look at this is to look at your last terms and say, if I were to multiply the last terms, would I get the last term? So if you look at A, if you multiply positive 5 and negative 2, those are your last terms, would you get negative 10? Yes, so that's a possibility. What about B? If you multiply negative 5 and positive 2, will you get negative 10? Correct. What about C and D? If you multiply the last terms, do you get negative 10? No. So those are not even a possibility. Okay. Correct. So you automatically eliminate C and D. Okay? To get your middle term, so your first term would be your two first ones, and they're all the same. X times x is x squared. The last term is the last terms multiplied. We narrowed it down to A and B. The middle term is when you add your outer and inners. So what I mean by that is outer terms are x times negative 2 on A, negative 2x, and positive 5 times x, positive 5x. On B, it's x times positive 2, positive 2x, and negative 5 times x, negative 5x. So if you add those up, on A, negative 2x plus 5x is 3x. On B, 2x minus 5x is negative 3x. Only one of those is the middle guy for 70. Do you see that? So it's your outer and inner added together. So only one of those works, which is A. The other one gives you the negative, and you don't want the negative, you have to want positive. Yeah, exactly. So in order for something to be a factor, then if you plug an x into the group, it has to give you 0. That's the only way it can be a factor. So they've given you several points here. They've given you negative 1, 0, negative 1, or negative 3, 0, sorry, negative 1, 3, 0, 2, and 1, 0. You see that? The points on the graph, okay? So in order for something to be a factor, you have to be able to plug in your x and get 0, okay? So if you look, there's only two places that give you a 0 for your y on the graph they gave you. It is at negative 3, 0, and positive 1, 0, okay? Do you see those 2 points on the graph? Okay, so that means the only groups that are factors are the ones that will give you a 0 if you plug in negative 3, or a 0 if you plug in positive 1. Okay? It's the only way to get a factor. So if you look at all of those groups, which of those groups gives you a 0 when you plug in negative 3, or a 0 when you plug in positive 1? So you want to plug in a negative 3, meaning replace x with negative 3 and get 0. So which of those groups will give you 0 if you put a negative 3 in for x? I plug a negative 3 into this one, it doesn't work. What about the one to the right of it? X plus 3. Negative 3 plus 3. Does that one give me 0? That is a factor. If you plug in your x and get 0, it's a factor. All right, what about x minus 1 and x plus 1? Obviously, we're not going to plug in a 3, so let's try positive 1. That's my other 0. Which one of those, if I plug in positive 1, will give me 0? So if you plug in a positive 1, 1 minus 1 is 0. Yep, that is a factor. X plus 1 will not work. 1 plus 1 equals 2. And we know the 2's don't work because the only things we can plug in here are negative 3 or 1. So we know those 2's do not work there. So those are the only two options. Correct. Correct. Number 71. The graph of the exponential function is shifted up 2 units to create this new function. So it gives you the graph, and it wants you to shift it up 2. Remember I said if you have a function on the outside, you add or subtract, that just slides it up or down. Like the parabola, the smiley face would go up or down. When you add something, same true of any function. So if they wanted to move a function up or down, you just add or subtract the outside, on the outside of it. So which one of these is moving it up 2 units? Which one is adding 2 on the outside? Remember, yeah, B, because the multiplying stretches it, remember? Multiplying stretches it, adding and subtracting moving it up or down. Minus 2 would move it down, plus 2 would move it up, and they're asking us to move it up, correct? So that one's actually easier than it sounds. Okay, this next one's kind of a trick question. So first, do you think this next graph is pointing down or up? Down because of the negative 2. So we're taking 3 to a power, like 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27.
First of all,
3 to a power. And then it would normally look like that number 71. That's what exponential functions normally look like. They shoot up real far. But when you multiply them by a negative, they do exactly what the parabola did. They go down.
Mom, can you please tell her I said hi?
So we automatically know that it's going to be one of those negative infinity ones, okay? We automatically know that. So we can eliminate A and B, okay? We can also eliminate C, because C is also going to infinity. And this guy's pointing down permanently, right? Does that make sense?
Does that look better?
So we know it has to either be D or E. Now, what's the difference between D and E? Can you see it visually? Right. So bracket means it includes the number, and the parentheses means it doesn't include the number. So here's a little hint. If you have 3 or any number to a power like that, it can never include 0. I can never take 3 to some number and make him 0. The only way I can get 3 to be 0 is to subtract 3. And this equation does not subtract anything. So it is going to go to 0, but it won't actually include it. And so the parentheses means does not include, and the brackets means does. So you'll notice the infinities always have parentheses, because infinity is not actually a number, so you can never actually include it. But the 0 has the option. While when it's a number to a power, it will never ever equal 0. So it can never include that 0. So you have to indicate that with that parentheses, not the bracket. Domain just means to put it in for X. Range means what is your answer. So this just means plug a 2 in where your X is, and what is your answer going to be. Now remember, you have to do order of operations. So for this, you're just going to plug a 2 in for your X. So 2 to the 2. So you have 3 times 2 squared. In order of operations tells you to do the 2 squared first, exponents first. So 2 squared is 4, and then you're going to multiply by the 3. So remember, anytime they say domain, that means put that in for x. Range just means what is your answer when you put in that number for x. So what's your answer when you do 2 squared and then multiply it by 3? Mm-hmm. Mm-hmm. Correct. All right, so let's look at this next one. It's kind of a weird way to word this question, but I'll explain it to you. The equation y equals 2 to the x represents the number of sections y a sheet of paper has after x folds. So like 2 to the first power. You take a piece of paper, you fold it once, 2 to the first, once. You have 2 sections, right? Y. If I fold it twice, 2 to the second power. So I take that paper and I fold it in half again. 2 to the second power is 4. When you unfold the paper, you'll see 4 sections. You see that? So it's telling me the point 3, 8 falls on the graph. Remember, x represents the number of folds. They told you that. Which of those is your x value, 3 or 8? So how many folds have you done then? If x is the number of folds? 3. And then how many sections will you have on your paper after 3 folds? If y represents the number of sections, what's your y value there? There we go. So it says after blank folds, the paper has blank sections. How would you explain that? After how many folds, based on that point, the paper has how many sections? Look, so what does it tell you? Which one of those represents folds? So what are you going to put for folds? And then what represents sections? There we go. That's all that means. So anytime they tell you what x is and they tell you what y is, then in your answer you can say, oh, my x is this because they told me x was this, and my y is that because they told me x was that.